I welcome you all to this interesting lesson tonight. I guess you are all prepared for this wonderful lesson. So we are starting oxides. It's a continuation. We are doing acid, salts, and bases. So it is very important to also know what an oxide is. If I was to ask you a question, some of you, what is an oxide? Some of you be able to answer. Some of you won't manage to answer what an oxide is. So whenever we are talking about an oxide, you just need to understand that an oxide, this word oxide, we are just talking about a compound. So this is just a compound formed. So it is a compound formed when what? When oxygen, I'll say oxygen, let me just write it. So when oxygen reacts or combines, so when it reacts or combines with the other elements, so that compound that is formed is what we get to call an oxide. So what is an oxide? An oxide is a compound formed when oxygen combines with any other element. So when it combines with any other element, we get to form what we call an oxide. An oxide gets to be formed. So these oxides are put in classes. They are what we call classification of these oxides. It's very important for you to know this. Classification of what? Of oxides. So I want you to know the classification of these oxides. So they are put in classes, and you need to know that first of all, they are what we get to call acidic oxides. So if I tell you, give me two examples of acidic oxides, you must be able to give me those examples. So you ask yourself, what is an acidic oxide? So you need to understand that acidic oxides, these are oxides that are called the oxides of non-metals. In other words, an acidic oxide, this is a compound formed. So this is a compound formed. A compound that is formed when oxygen. So I'll say when what? When oxygen reacts with a non-metal. With a what? With a non-metal. So acidic oxides, we are saying that these are oxides of non-metals. So what are acidic oxides? These are oxides of non-metals. So when oxygen reacts with a non-metal, we get to form an acidic oxide. For example, we've got carbon dioxide. So have you seen? This is an example. This is carbon dioxide. So how is it formed? You discover that when carbon reacts with oxygen, what is formed is what? Carbon dioxide. This is a perfect example. We can also look at nitrogen dioxide, which is like this. This is nitrogen dioxide. How is this formed? You discover that when nitrogen like this is nitrogen, when it reacts with oxygen that is also written like that, what we are going to form this side is what we are calling nitrogen dioxide. So there is a 2 that is there. These equations are not balanced, especially this one. I've not balanced it. But if you want to balance it, some people like writing balanced equation like this. So in chemistry, you need to make sure that you write balanced chemical equation. Just put a 2 here and a 2 there. So meaning this one is what? Is balanced. I guess we are moving together. What is an acidic oxide? These are oxides of non-metals. What do we mean by when we say oxides of non-metals? When a non-metal reacts with oxygen, or when oxygen reacts with a non-metal, what is formed is what we get to call acidic oxide. I guess we all know what non-metals are. We've got quite a lot of them. So this is you need to be writing names here. This is what? Carbon dioxide, lest you forget. This is carbon dioxide. This one that is here, this is nitrogen dioxide. So this is nitrogen dioxide. We've got quite a lot of them. So the next thing that there is also what we call sulfur dioxide. So we've got sulfur dioxide. How is sulfur dioxide? Sulfur dioxide is just like this. All these are acidic oxides. We've got sulfur trioxide. So when we say sulfur trioxide, sulfur trioxide, tri means 3. So meaning it is SO3. This is sulfur trioxide. So this is the information that you are supposed to know. This is something interesting. I guess you are enjoying this. So you just need to make sure that you get to follow me clearly and attentively. These are just examples, but the key point, I've said that when a metal reacts with a when oxygen reacts with a non-metal, we get to form acidic oxides. So this is one thing that you need to know. So you now discover that when we are talking about acidic oxides, so one of the characteristics of these things is that when acidic oxides dissolve in water, they get to form acids. So one of the characteristics, so whenever we go to characteristics, I guess people are getting this. I just want you to know this. You should not even master this. You just need to know this. So I'm saying that one of the characteristics of these acidic oxides. So I've told you that the characteristics of what? Acidic oxides. One of the major characteristics of acidic oxides is that when they dissolve in water, so when you dissolve these in water, you discover that, so one point that I've said here is that when acidic oxides, so I'm saying that when acidic oxides, these acidic oxides, when they dissolve, so acidic oxides dissolve in what? In water. Once they dissolve in water, they form what? Acids. So when they dissolve in water, they form what? They form acids. So when they dissolve in water, they form what? Acids are formed. They get to form acids. For example, carbon dioxide. When carbon dioxide dissolves in water, when you react it with water, you discover that what is going to be formed here is what you are calling a carbonic acid, which is going to be like this. So the key thing is that when an acidic oxides dissolve in water, you get to form acids. Acids are what? Are produced. So an acid is produced. That's a point that you need to understand. So there are a lot of these things that you need to know when this reacts with this. So you just need to know, okay, when a carbonate, this is carbon dioxide, when it dissolves in water, you get to form what? Carbonic. This one is what we are calling a what? This is what we are calling a carbonic acid. So this is a carbonic what? A carbonic acid. You can try to get, let's say you get this one, which is the sulfur dioxide. When you dissolve it in water, you even know, okay, where there is sulfur, an oxide with sulfur. This is what? Sulfuric acid. You get to form the sulfuric acid. So this one is what we are calling sulfuric acid. You get to form what? Sulfuric acid. So these are just examples. This is just to show you how these things are being formed. So you discover that when we are talking about dinitrogen tetraoxide, so that one, when you discover that it when you dissolve it in water, so the one that I'm talking about is this one. Chemistry is so sensitive. I can be saying some names here that people are not getting. So when I say dinitrogen tetraoxide, so what I mean is this one. This is what I mean. Have you seen this one? So what is the name of this? N2O4. This is called dinitrogen tetraoxide. So when this one dissolves in water. So when it dissolves in water, it gets to form two acids. What are the name of these two acids? We get to form what we call a nitrous acid, which is like this. This is a nitrous acid. So we get to form a nitrous acid plus what we get to form a nitric acid. Two things are being produced, and these are acids. So you need to know that when this, what is the name of this N2O4? What do we call this? What is the name of this? This is called di. Have you seen there is this word two? Two is di. So we are saying 4, we say tetra. So that is why I'm saying dinitrogen tetraoxide. So dinitrogen meaning 2 nitrogen, tetra meaning 4 oxide. That's why I'm saying dinitrogen tetraoxide. When it dissolves in water, you get to form this. These equations will really help you improve your skills in chemistry, so that you know, okay, when this reacts like this, they get to form this. When this reacts with this, they get to form this, and that. You discover that they are called acidic oxides because they react with water to form acids. So if I ask you a question to say, why do we call them acidic oxides? You must be able to tell me that the reason why they are called acidic oxides, it is because they dissolve in water or they react with water to form acids. This is the reason why we call them acidic oxides. So when you ask me, sir, why do we call them acidic oxides? So if you can forget, it's very important for you to write down this point. So we get to call them acidic oxides because they react or dissolve in water to form acids. This is the reason why we call them acidic oxide. So this is the major reason we call them what? Acidic oxides. So now, I want you to understand one thing. I want you to know one thing. We are talking about oxides and we've talked about acidic oxides. Aside acidic oxide, there are also what we call basic oxides. These are also very important for you to understand. So aside acidic oxides, there are also what we get to call basic. We call them what? Basic oxides. So the name that is given to this, tonight's lesson is very simple. This is a short lesson that you can come across even in an exam. So the second thing is called basic oxides. So when we say these are basic oxides, you need to know. Why do we call them basic oxides? So when we say basic oxides, these are oxides of metals. So they are what? These are what? Oxides. Oxides of what? Metals. When I say oxides of metals, one thing should click in your mind. They react with the metals. So you discover that these ones, they are formed. So we are saying that they are what? They are formed. So we are saying that they are formed when a metal, when a what? When a metal reacts. So when a metal reacts, so these ones get to be formed when a metal reacts with what? When a metal reacts with oxygen. So when a metal reacts with the oxygen, we get to form what we call a basic oxide. So when I tell you, give me 2 examples of basic oxides. Basic oxides, these are oxides that are formed when a metal reacts with the oxygen. So when a metal, I guess you know what metals, group 1 elements, group 2 transition elements, all those are metals. So when they react with oxygen, they get to form what we call basic oxides. Example of those, we've got what? We've got sodium oxide is a base example that we can consider. We can talk of copper. We can talk of copper 2 oxide. This is also an example. We can also consider iron 3, I would say iron 3 oxide. it is like this. Iron 3 oxide, which is like this. These are examples: calcium oxide, magnesium oxide, potassium oxide. All those are examples that you are supposed to know. So these are what we call what? These ones we call them what? We get to call them basic oxides. So when they react with what? When they react with the metals. Specifically, these ones, you have to understand them this way. So now, what you need to understand is that under this, the way they get to be formed, you discover that these ones, when they these are soluble basic oxides, they get to dissolve in water to form alkalis, which is a base in simple words. So you discover that one of their characteristics is that these ones, they, so I will say somewhat, I will say some soluble basic oxides. So not everything, but somewhat basic oxides, some soluble basic oxides dissolve. They do what? They dissolve. They get to dissolve in, so they get to dissolve in what? In water. They dissolve in water to form what? To form alkalis. They get to form what we get to call alkalis. Example, when we are talking about the same one, sodium oxide, when it dissolves in water like this, what do we form this side? Sodium hydroxide. To balance it, put a 2 there. So this is something that I just wanted to make you understand. You also discover that basic oxides react with acids to form salt and water only. So another point is that these ones, basic oxides, so we are saying that they do what? They react. They get to react with what? They react with acids. So they are going to react with acids to form what? They are going to form a salt. A salt and water. Salt and water. Salt and what? Water only. So this is what you have to know. So these ones, they react with acids to form a salt and water only. Example, we've got, I will just pick that one, sodium oxide. When it reacts with hydrochloric acid, what we are going to form is sodium chloride plus water, H2O. So that is water that is being produced. So you just need to understand that. Then a third category that you need to understand. So a third category is, so the third one is what we get to call what? Amphoteric. We get to call this as amphoteric oxides. So amphoteric oxides, what you need to understand, these are also oxides of what? They are called oxides of metals. We also term them as oxides of what? Oxides of metals. That's how we also get to term them. I guess you are able to understand, though I'm a bit fast, but you are able to relate to what I'm saying. These are just notes, and I guess you are moving with me. You are able to write down some notes. So amphoteric oxides, these are oxides of metals. But these ones, they are some kind of what? Limited. For example, you discover that, for example, we've got zinc oxide is an example. We've got aluminum oxide like this. This is how it is. We also have lead 2 oxide. These are examples. So this is lead 2 oxide. This is aluminum oxide. This is zinc oxide. This is how they are. So you now discover that these ones, amphoteric oxide, show that basic and acidic properties. They show what? Basic and acidic properties. You discover that they react with both acids and alkalis to form salt and water. They are going to react with both acids. Have you seen? So these ones, these amphoteric oxides, I'm telling you that they do what? These amphoteric oxides, what am I telling you? I'm telling you to say that they do what? They show. These ones get to show what? They show both what? Both acidic, so say they show both acidic and basic oxide. Basic, I will say basic properties. So acidic and basic what? Basic properties. This is what you are supposed to know. They get to show basic and acidic properties. You discover that when they react with acids, they are going to produce a salt and water. When they react with alkalis, which is a base, they are still going to produce a salt and water only. These are the only products that get to be produced. So I guess you are able to understand this. Aside amphoteric oxides, there are also what we get to call what? Neutral oxides. So there are 4 of them, and you just need to understand these are oxides. They are put in categories. So I want you to, when I say, okay, this is an amphoteric oxide, you need to know that, okay, so this one gets to show both acidic and basic properties of what? Of metals. But there is also what we call what? What we call neutral oxide. It is called neutral oxide because these are oxides of non-metals. They may look same with what? With what we talked about, which was acidic. But with these, you discover that neutral oxides do not show either basic or acidic properties. They do not react with either acids or bases. These ones, they don't react. So what I'm talking about is this. So you need to know this. You need to make sure that you understand this information. They may look somehow similar. So I'm saying that these ones are called what? Neutral oxides. So they are called neutral oxides because these are what? These are oxides of non-metals. These are oxides of what? Oxides of non-metals. So they are oxides of what? Non-metals. We get to call them oxides of non-metals. Why are they called oxides of non-metals? Because these ones do not, you need to understand that, do not show, these ones, they don't show either basic or acidic properties. Basic or acidic what? Acidic properties. They don't show basic or acidic properties. They don't react. They do what? They don't react, and they will never react. They don't react with what? With acids or alkalis. So alkalis, we can also say bases. It is just one and the same. So they don't, these ones they don't. But these, the ones that I'm talking about, which are called amphoteric, those are oxides of metals, but them, they react with the acids and bases, and they show their basic and acidic properties, but these ones, they don't. Examples of these ones, you get to talk of what? Carbon monoxide. Carbon monoxide is a good example. How is it? It is just like this. Secondly, we can also talk of what? Nitrogen. We can talk of nitrogen monoxide is an example. Nitrogen monoxide, which is just like this. We can also talk of what we get to say dinitrogen oxide. So dinitrogen oxide. How is it? This one is just like this, N2O. So it is N2O. You just need to understand it that way. That's how it is. We also get to talk of water, which is hydrogen oxide. So water is an example of a neutral oxide. We've got water. We also have, think these ones are enough. We can at least try to answer 1 or 2 questions. So we are done with the acid, salts, and bases. The next thing that we are going to start, today's lesson was just about oxides. And I guess you know what oxides are. You are able to list 4 classes of oxides: basic, acidic, amphoteric, neutral oxides. 4 of them. So after this lesson, study through this, understand them. The next thing we are starting are the salts. That's the next thing that we are going to start. So I want you to follow this. I want you to understand this very well. I'll give you an exercise, a simple exercise. I see how you've understood this part. So today we were just looking at oxides. And after this lesson, you must be able to know all the oxides that are there. Study through these things. When I say, give me 2 examples of amphoteric oxides, you need to know what is an amphoteric oxide. You must be able to tell me, okay, amphoteric oxides, these are oxides of metals, but them, they get to show both properties of acidic and basic. They are also what we call neutral oxides. These ones, they are what? Oxides of non-metals, but they don't show either basic or acidic oxides. And you must know that them, they don't react with the acids or bases. So this is something that you need to know, something you have to understand. It is very simple. These are sweet things. These are wonderful things that you need to be taking advantage of, even in an exam. So make sure you know this. Make sure that you understand this. This is something that is so interesting, something important, and something sweet. So this is where we are going to end from. Let's see how you are going to attend to the exercise. Make sure you try to, you need to be saying these things. Okay, acidic oxides is this, basic oxides is this, after this lesson, so that you know them. Tomorrow when we start, next time when we meet, we need to progress. So this is where we are going to end from. And I guess, don't say you are going to study tomorrow. Tomorrow never comes. So make sure you study immediately after this lesson. Know this, understand this. Tomorrow, there is another week waiting for you. So if you keep on postponing work, you discover that by the end of the day, work will be packed waiting for you. And tomorrow is an exam. That way, we don't study that. So let's study this. Tomorrow, we've got another work for tomorrow. So let's just make sure we study through this. And I guess we've written down notes. This is where we end from. Thank you so much. So like I've told you, don't want to remove anyone from the group. So let's make sure that we do the needful. If your payment is done, make sure you clear your payment. I don't want to remove anyone from the group. So, but if your payment is done and you've not communicated, you'll be removed. In as much as I don't want to remove, but if your payment is done on that one, you just see that you are removed from the group. Thank you so much.